Welcome to Microsoft Build 2017. I'm Hari Pulapaka, and I'm here to show you Windows 10 on ARM. I'll show you some cool demos and then finally prepare you, the UWP developer, how to get ready for Windows 10 on ARM.
And I'm Arun Kishan, and I'll talk a little bit about how our x86 emulation technology actually works.
Let's get started. So over the next 4 years, over 1 billion new users will be connecting to the internet for the very first time. And cellular connectivity is a big reason why. Cellular speeds will get faster and cheaper as we progress over time. Even today, our customers have multiple connected devices, either on Wi-Fi or LTE. They always expect connectivity, whether they're on the bus ride home or at the coffee shop or at their school. So as we see this landscape, we see that we see an opportunity for Windows to increase its capabilities. So we need to build devices that have inbuilt cellular connectivity and great battery life. So as we see this, we are introducing Windows 10 on ARM. These new Windows 10 on ARM devices will be powered by Qualcomm Snapdragon processors, which provide inbuilt cellular connectivity and a great battery life. Now, of course, Windows 10 on ARM will be the full desktop experience that you are familiar with. It will have the things that you're very familiar with, for example, Edge, Cortana, Hello, and Ink. In addition to just the basic Windows experience, you also have all of the apps that you're used to. For example, all of the UWP apps in the store, all of the Centennial apps will be available on Windows 10 on ARM. And not just that, Windows 10 on ARM will also provide you with full support for running x86 Win32 apps. That's right, your existing x86 Win32 apps will run completely fine on this device through the magic of the x86 emulation layer. So with that said, let me show you a quick demo of how this works. And let's see this. You're actually seeing this. What you're seeing right now is actually we are running the entire PowerPoint presentation off a Windows 10 on ARM PC. What we have here is actually an engineering device built by Qualcomm. This is what we are using inside Windows and Microsoft to develop Windows on ARM64. Now, of course, this is not what we are really shipping. Our OEMs that are building Windows 10 on ARM devices will be shipping real form factor devices. There will be 2-in-1s, there will be laptops, and these will be available in the market later this year. So with that said, let me show you a quick demo of the Windows 10 experience. We are running the full Office on this. This is Office 2016 PowerPoint. You have the full set of Office apps running on this device. With that, let's pull up the system properties. And you can see the system properties right here. And you can see right here, we are running Windows 10 Pro Insider Preview on this machine. It's running on Qualcomm Snapdragon 835 processor. It has 4 GB RAM and running a 64-bit ARM operating system. Now, as this is the full Pro SKU, you can actually domain join this machine if you want to, right here. I haven't, of course, domain joined this machine because it's a test machine. Let's pull up Task Manager right now. And let's go to the Performance tab. And here you see all of the 8 cores of the Qualcomm Snapdragon processor, 4 big, 4 little. Let's launch Edge. You see that launch? It was smooth, fast, instantaneous, super smooth scrolling. Now, of course, when you think about Windows 10 experience, it's not just the desktop. In addition to the desktop, you have the apps and you have devices. Now, Windows 10 on ARM will have great device support for USB peripherals using the inbox class drivers. So let me show you a quick demo. What I have here is a USB camera that I bought off of Amazon. And that's it. I'm going to plug this into the machine and it's just going to work. No drivers, nothing. And so let me launch the camera app right here. And there you have it. You can actually see the studio. Cool. So what you saw till now, let me close the camera app so that we are not distracted. So what you saw actually till now was the native experience. Everything that you saw till now was actually ARM code running natively with great performance inbox. Now what about your existing x86 Win32 apps? So now I'm going to show you a quick demo of existing x86 Win32 apps through the magic of x86 emulation layer. Now, here's a scenario that most of you have probably encountered at some point in your life. Your friend sends you a set of files. He zips it up using an open source software like 7-Zip. And if they send you that file, what do? You go online, you search for 7-Zip, download 7-Zip, and install 7-Zip. And so if that happens to you on a Windows 10 on ARM PC, what do? You do exactly the same thing. You go online, you search for 7-Zip, download 7-Zip, and install 7-Zip. And so I've actually already downloaded 7-Zip and stored it on desktop to save some time. So I'm just going to run through it. I'm going to show you the install of the 7-Zip so that you can see it's exactly the same. Let's start. You see the UAC prompt. Click yes to install. And let's install the UAC prompt. And that's it. That was 7-Zip installed on this machine. Again, to remember, this was the standard 7-Zip installer off the internet with no changes. And just to show you that it's real, I'm going to launch 7-Zip, which is right here. There you have it, 7-Zip. So with that said, I'm going to hand it over to Arun, who's going to spend some time and talk about how exactly this magical emulation layer works.
Thanks, Hari. So I'll talk a little bit about how the x86 Win32 emulation actually works. We basically have the existing apps run unmodified. So there's no user or app developer intervention required. It just works. You install it, and the binaries just work just like on any other PC. So we'll talk a little bit about how that actually works here. So I'm going to click through a few diagrams. So here you see a diagram of what a typical process on the OS looks like. This is a native process, meaning it's running native ARM64 code. And so Windows, the Edge browser, or the shell, they're all examples of native processes. And then you have native system DLL, so the OS libraries. Then you have something called NTDLL, which is a special system DLL, which is how apps talk to the kernel. And down here, you have in kernel mode, the actual Windows kernel and the drivers. And they operate with devices like the GPU, disk, and networking, basically at hardware speeds. So these native processes, which are all the inbox experiences, basically run at the full capability of the ARM64 hardware. If you go ahead to the next. Here, this is what an emulated process looks like. So in an emulated process, it runs on top of our WoW layer, which is Windows on Windows. It's a similar infrastructure that we have on x64 PCs to run x86 apps. In these apps, you'll have x86 code, so the app executable and the system binaries that you saw here, we have the x86 versions. And then you kind of have a second part of the process, which is all native code. You have the WoW abstraction layer, which I'll talk about in a minute. You have a CPU emulator, which traditionally on a normal 64-bit PC runs in hardware, just runs a 32-bit code in hardware. But on ARM, we don't have that. So we've implemented what's called a dynamic binary translator, which will look at chunks of code and at runtime translate them to blocks of ARM64 code, which it will cache in memory or on disk for subsequent use. Now, all the system calls, it's important to notice they all go through the same native system NTDLL, and then they talk to the kernel, at which point any interaction with the kernel or with these devices again run at native hardware speeds. Now I want to go back to this WoW abstraction layer for a second. You might be asking yourselves, why are we running all these x86 inbox system DLLs emulated? Well, there's a couple reasons for that. If you think about the application talking to these binaries, they're talking to the binaries via 32-bit data types and 32-bit x86 calling conventions. So if you were to translate to run the native DLLs at these boundaries, you would have to thunk every single one of those APIs, which means you convert the data types back and forth from 32 to 64, and you'd have to marshal the calling convention. The calling convention marshaling could be automated, but the data type marshaling is a big undertaking. So a trade-off we've made is we actually do that data type marshaling only at this layer, and we run all of this emulated. And that's a pretty good trade-off when you think about x86 on x64, because the hardware can actually run these at basically native speed. So the fact that they're x86 doesn't really make a difference. But when you talk about a dynamic binary translator, you're incurring overhead for running all this code. So one of the things we've worked on in conjunction with the developer group and the compiler team is to develop a technology called CHIPY, or Compiled Hybrid Portable Executable Files. So what these are is these basically are generated from the same code that we have in the system, except that they're ARM64 code with calling convention interop, and they still operate on the 32-bit data types. So we've automated the calling convention, but we are still able to operate on the 32-bit data type. So the data type thunking only occurs at this layer, But for the most part, these run at native speed. So these are effectively like perfectly pre-generated binaries that you can use in the process. So as you can see, we've moved a lot of the code down into this native section. So depending on the mix of time spent in between the app code, system code, and kernel, you can get near native or very close to native performance with this approach.
Thanks, Arun. So with that quick dive from Arun into the internals of the x86 emulation layer, let's take a look at UWP apps. I'm going to show you a demo of some of our UWP technology and talk to you why this is important. So let's launch the store app. There you see the store app launching. It's almost instantaneous. Let's search for the very popular iHeartRadio app. So iHeart. There you have it. Let's install iHeartRadio and let's launch it. So I've already installed it previously on this machine to save some time. So let's just launch iHeartRadio. And there you have it, iHeartRadio. Launched instantaneously. Perfect performance, great, smooth, really smooth scrolling. So what you're actually seeing right here is the UWP app running natively on ARM. Remember, x86 apps run unemulated, but your UWP apps run native. And to show you that it's running native, let me pull up Task Manager here. So when I pull up Task Manager, you'll actually see that iHeartRadio is running 32-bit. This is running 32-bit ARM. And to show you that it is a 32-bit ARM package here, let me open up properties. And you can see that it's actually the ARM package. Now, the iHeartRadio app obviously did not need to make any changes. It just ran as is. It was submitted to the store, and it ran as is. The store app actually is also running natively, and I can show that to you again. You just open Task Manager, look at store, open up properties, and you will see that it's actually an ARM app. So with that, let's switch over to the slides once more. So with that demo on the UWP apps, let's talk a little bit about what you just saw. What you saw actually was the UWP app running natively on this Windows 10 on ARM device. The UWP apps actually stand for Universal Windows Platform, and they're living up to their name of being universal. These apps required no changes. These apps were submitted to the store, and they ran. We just downloaded them, as you saw, and they just ran. No, UWP apps do not need to change their code at all. We've proven this, in fact, across Microsoft. Most of our UWP apps inside Microsoft were just packaged for ARM, and they ran as is. Most of them required 0 changes. So if you thought UWP apps, or your ARM package for UWP apps are only for the phone, think again. Windows 10 on ARM is coming. So if you're a UWP developer out there, submit your UWP apps, the ARM package, to the store. And with that, the call to action. What you just saw was a demo for Windows 10 on ARM that's coming later this year. So if you're a UWP developer, submit your ARM apps to the store. If you have any questions, please send us email at the email address. And thank you all for watching.